Okay, let's go ahead and go to homework 18. So what will happen to the equilibrium under the following conditions? All right, so pressure goes up. Okay, so how is pressure going to what's pressure going to do in this particular case? So Le Chatelier said any stress in an equilibrium reaction, the equilibrium reaction attempts to undo the stress. So the stress is an increase in pressure. So what's the reaction want to do? Decrease pressure. Whatever happened, the reaction wants to do the opposite of that. So what could this reaction do, shifting to the left or to the right, to reduce the new pressure, the new higher pressure in the container?
Right side.
If it goes to the right side, it took 4 particles on the reactant side, 4, yeah, 1 nitrogen and 3 hydrogen gases, and turned them into 2 particles on the left side. You okay with that? So those 4 turn into 2, and so I've halved the pressure from those because now I've only got 2 particles instead of 4. And Dalton's law would say that the only thing that matters for pressure is the number of particles in the container, because the container's temp and size remain the same. So all I need to do is reduce the number of particles, reduce the number of moles. So on the right side, the reactant side, I've got 4 moles. On the product side, I've got 2 moles. So I can reduce the pressure by simply combining substances. So 4 moles turns into 2 moles. Okay, so I introduce more nitrogen to the container. So the stress is more nitrogen is now in the container. So what's the reaction want to do? Get rid of the nitrogen. So how does it get rid of the nitrogen? Combines it with the hydrogen and turns it into ammonia. So this is also going to shift. Okay, some hydrogen gas is removed. So the stress is H2 is missing. So what's the reaction try to do? Replace the missing H2. So there's only one way to replace the missing H2, and what would that be?
Take it from NH3.
Perfect. So it's going to shift to the reactants to replace lost hydrogen gas. Okay. So that's the kind of stuff that we're looking for with this. These questions, these Le Chatelier principle questions. All right, so you want to calculate the rate constant and determine the rate law. All right, so let's see, we've got let's do 1 and 2. So I got a 1 there, got a 2 there. No, I can't do that one. Sorry, that one changes too. All right, so let's do here. It goes up by 2, goes up by 1, goes up by 1, and what happens to the rate? It goes up by 2. All right, so it's first order with respect to A. All right, so let's do 2 and 6. 1, 2. If I go upwards, it's double. And then what's going on here? Four times greater? Yeah, 4 times greater. All right, so then it's second order with respect to B. And then what about C?
No change.
Nothing. So let's see, we can do,
Yeah, trials.
which trials are we doing?
And 3 and 6.
1 and
One. Yeah, 1 and 6. Okay, so no change there. No change there. Goes up by 2. And no change there. All right, so it's 0th order with respect to C. So I actually didn't even say this when we were doing that example last class, but anything raised to the 0th power becomes what? 1. So it just drops out of the equation. So C in this example must not be involved in the rate limiting step. And how do we describe the rate limiting step? We're thinking about the reaction mechanism, and there's several steps that happen over the course of the reaction to get my product. What's the rate limiting step? What's a good analogy for that? Or a phrase you could use? No, that's something that runs out first. I would say chokehold or bottleneck. That's the bottleneck reaction. And C is not involved in the bottleneck reaction. Maybe C happens before or after the bottleneck reaction. And that reaction that C is involved in happens like in nanoseconds, where the bottleneck reaction takes milliseconds. So it doesn't matter how long the reaction with C takes. If it's 1,000 times faster than the other reactions or 1,000,000 times faster, then it happens instantaneously. And so it won't slow or speed the reaction up, changing its concentration. So C, no impact. All right, so then the rate constant, we'll just pick anything. So I'll just do the first one. So 2.3 times 10 to the -8. That's weird. Equals K. And then we got 4.3 times 10 to the -4 to the first, and 1.6 times 10 to the -4 squared. So K is equal to 2.3 times 10 to the -8 divided by 4.3 times 10 to the -4 times 1.6 times 10 to the -4 squared. So yeah. 0.3 E -8. 2.3 divided by 4.3 E -4 divided by close parentheses 1.6 E -4 close parentheses caret 2. So we got 2 sig figs here, so it's K is 2100. So the actual rate law for this is going to be rate equals 2100 A to the first, B to the second. Okay, how can you remove toxic metal without using a filter?
introduce a salt.
Okay. What about the salt is going to help?
It's going to bind to the metal ion and create a precipitant that
Okay,
you
so the
can
salt
take out.
is soluble. So the salt is soluble. But anion of salt will precipitate out the metal. So we did this before, but the easiest example is probably you've got lead floating around in the water. You don't want to drink the lead. You introduce magnesium sulfate, which is what? Epsom salt, which you may or may not have on hand, but regardless, you end up with PbSO4 solid and Mg +2 aqueous. So is that an okay thing? You'll drink water with magnesium in it and not even really know. It won't have a flavor, although if you add Epsom salt to water, there'll be a slight texture change. I think that's the easiest way to say it. Like if nobody tells you, you probably won't notice. But if you just did it and drank it, you'd be like, there's something tiny bit different about this. There is no sodium flavor whatsoever. Just because it's a salt doesn't mean it's sodium. It's got to have the sodium in it. So you don't have any taste buds for it. It's just the fact that there are ions in the solution will make the taste buds in your mouth feel a little bit different. So that's why people will add Epsom salt to water if they're like, what would a reason that you'd want to take Epsom salt as a supplement or as a medicinal thing?
Magnesium deficiency.
Yeah, not super common unless you're like really working out and not eating well. I mean, magnesium is definitely an incredibly important part of the electrolytic system between the neurons. Also helps with, transfer of stuff in and out of cells. It's one of the 3 ions you need for one of the 4 ions you need for a heart to be able to actually beat. But what are the more common reasons somebody would want to add magnesium to their diet? 2 really common reasons. One is
isn't that like
maybe TMI. Say again?
Sleep drug? Like helps you go to sleep?
No. Melatonin.
Right.
Say again?
And like anxiety.
I've never heard of that, but maybe. Can't poop. It helps motility. It increases the concentration and causes this osmosis issue to occur where more water gets put into the colon when the magnesium ions end up in the colon. So it just literally helps flush you out. So too much magnesium can, give you diarrhea, but that's not usually very common. It's more like you're constipated or your 1-year-old's constipated. You can add it to some water. And that's one of the reasons Pedialyte's a thing, although that stuff is horrible. So don't give your kids Pedialyte. You should never give your kids high fructose corn syrup under any circumstances. And then the other reason is it's a muscle relaxer. So it's definitely something you could use if you're hurt your back or something, or really sore after a long run, hike, bike ride, something like that. It will allow the muscles to transition out of it'll get stuff into the muscles, will help repair all of those micro tears that you did during the workout. So muscle relaxant, and it won't give you that horrible, I just had Flexeril. I don't know if you've had Flexeril as a muscle relaxant, but the next morning it feels like you drank a lot. It's not a good thing, but it definitely relaxes you. And you can get away with it, but just using the magnesium. So adding this to water, I mean, if there was a post-apocalyptic situation going on, I'd get my hands on just hundreds of pounds of magnesium sulfate just to have it on hand. Be one of the things you definitely want, especially if it's sort of this could be worse, right? What if it's this? What if that's the metal ion in the water? What's that? Uranium. Problematic. Uranium is not really a problem unless it gets into you. So you would definitely, the worst thing that can happen to you is to drink, eat, or breathe in uranium. And once it's inside of you, it does massive damage. If it's on the outside of you, it can't do anything at all. Nothing. It can't get through into your body. So this uranium would precipitate out with the magnesium sulfate as well. was a weird Denzel Washington movie, The Book of Eli. Did we see that? They were basically just looking for the Bible. Like, who was the bad guy? It was
Commissioner from Batman. I don't remember his name.
the guy who was the wolf in the Harry Potter movies.
Yeah.
The vampire in that.
Gary.
Oldman. Yeah, Gary Oldman. Yeah. He was looking for the Bible so he could control people post-apocalyptic. But the coolest thing for me, science-wise, is somebody was trying to offer Denzel Washington water, and he just happened to have a Geiger counter, and he checked it, and goes click, and he's like, "Yeah, I don't need that." So maybe a Geiger counter could be helpful. Film badge. That's another thing. Get your hands on like Polaroid film. I know it's not available, or just regular film. Like they do still sell it. You could use that as is there radiation on this? Put it next to it and pull it out. And if it's got spots on it, that was radiation that hit that stuff. So you'd still need a red light so you could not expose the film. But I'm really sure how we divulged into how to survive post-apocalyptic, but cool. Hopefully that will help you.
Just preparation for the election season.